First, we will talk about what are integers. The word integer is originated from Latin word integer, which means whole. It is a special set of whole numbers comprised of zero, positive numbers and negative numbers, and denoted by z or I. So, in the diagram over here, we can see that all the numbers to the right of 0 are positive numbers like 1, 2, 3, 4, 5, 6, etc. And all the numbers to the left of 0 are negative integers like -1, -2, -3, -4, -5, etc. But 0 is neither positive nor negative. Now we will discuss about the addition of integers. Addition of integers is the same as addition of whole numbers but with negative integers. There can be two scenarios in which we can add integers. One in which that both of the integers have the same symbol or sign, and the second scenario in which both of the integers have different signs. First we will understand when both of them have the same sign. While adding two integers with the same sign, we need to add the absolute value and write down the sum with the given symbol or sign provided with the number. Here in the example number 1, we can see it is written plus 4 plus 7, which is equal to 11. First we will add the absolute values 4 and 7, which in turn gives us 11, and here the given sign is plus, so we will write plus. In the second example, we can see it is written -6 plus -4, which is equal to -10. First we will add the absolute values 6 and 4, which gives us 10, and then we will write the sign which is provided to us, which is the negative symbol, so we will write the negative symbol. Now we will discuss the second scenario in which both the integers have different signs. So when we are adding two integers with different sign, we subtract the absolute value and write down the difference with this number which has a greater absolute value. So for example, we can say -4 plus 2 is equal to -2. First we will subtract the absolute values 4 and 2, which gives us 2. And here we can see 4 has greater absolute value and 4 has the symbol minus, so we will write -2. In the second example, we can see it is written plus 6 plus -4 is equal to plus 2. First we will subtract the absolute value 6 and 4, which gives us 2, and we can see that 6 has a greater absolute value, so we will write plus 2. Now we will understand the subtraction of integers. While subtracting two integers, we need to change the sign of the second number which is being subtracted and follow the same rules as of addition. For example, -7 minus of plus 4 is equal to -7 minus 4, which is equal to -11. In the second example, plus 8 minus of plus 3 is equal to plus 8 minus 3, which is equal to plus 5. Now we will be understanding the multiplication and division of signed integers. While multiplying and dividing two integers, the rule is simple. If both the integers have the same sign, then the result is positive. If the integers have different sign, then the result is negative. For example, plus 2 into plus 3 is equal to plus 6. Here both of the integers have the same sign, which is plus, and that is why the resulting value is also a positive integer. In the second example, plus 3 into -4 is equal to -12. Here in the second example, one number has plus and the second number has minus. So as they both have different signs, the result is always a negative. Similarly, when we are dividing, plus 6 divided by plus 2 is equal to plus 3, because both of the integers have the same sign, either here in this case positive sign, so the resulting value is also positive. The second example, -16 divided by plus 4 is equal to -4. Here both of the integers have different signs, thus the resulting value is a negative integer. will discuss some common properties for integers. First, we will discuss the closure property, then the associative property, commutative property, distributive property, the additive inverse property, the multiplicative inverse property, and the identity property. First, we will discuss the closure property. According to the closure property, when two integers are added or multiplied or subtracted, the result should be an integer only. If a and b are integers, then a plus b should be an integer, a minus b should be an integer, and a multiplied b is also should be an integer. Some example can be 2 plus 5 is equal to 7, which is an integer. 2 into 5, which is 10, is an integer. 2 minus 7 is equal to minus 5, which is an integer. Second, we will discuss about the commutative property. According to the commutative property of integers, if a and b are two integers, then a plus b should be equal to b plus a, and a into b should be equal to b into a. Some examples can be 3 plus 8 is equal to 8 plus 3, which is equal to 11, and 3 into 8, which is equal to 8 into 3, is equal to 24. But for subtraction and division, commutative property does not obey. Now we will discuss about the associative property. As per the associative property, a, b and c are integers, then a plus bracket b plus c should be equal to bracket a plus b plus c, and a into bracket b into c should be equal to bracket a into b into c. Some examples can be 2 plus bracket 3 by 4 should be equal to bracket 2 by 3 plus 4, which is equal to 9, and 2 into 3 bracket 3 into 4 is always equal to bracket 2 into 3 into 4 is equal to 24. This property is only applicable for addition and multiplication. The fourth property which we will be discussing about is the distributive property. According to the distributive property of integers, if a, b and c are integers, then a into b plus c should be equal to a into b plus a into c. Example, we can prove that 3 into 5 plus 1 will always be equal to 3 into 5 plus 3 plus 1. First we will do the left hand side. So for 3 into 5 plus 1, so we will get 3 into 6, which is equal to 18. And in the right hand side we have 3 into 5 plus 3 into 1, which is equal to 15 plus 3, which is equal to 18. Since the left hand side and the right hand side are equal, hence we have proved the distributive property. The fifth property we will be discussing about is the additive inverse property. This property states that if a is an integer, then as per the additive inverse property of integers, a plus negative a should always be 0. Hence, negative a is the additive inverse of a. Example, 4 plus negative 4 is equal to 0. The sixth property we will be discussing about is the multiplicative inverse property. This property states that if a is an integer, then a into 1 by a should be equal to 1. Hence 1 by a is the multiplicative inverse of the integer a. Example, 9 into 1 by 9 is equal to 1. Now we will discuss about identity property of integers. Under addition, whenever an integer is added to 0, the answer will be the number itself. Thus 0 is the additive identity. Example, 9857 plus 0 is 9857. Now we will discuss about the identity properties of integers under multiplication. Whenever an integer is multiplied with 1, the answer will be the number itself. Thus, 1 is the multiplicative identity. Example, 11,987 into 1 will always be equal to 11,987.